Kia ora Year 12 and Year 11. This video is question 8 from last year's Pure 1 paper 1-1 from the October-November 2021 series. And I've picked out the question on functions to start with because I think it's one of the places that people redoing this who haven't done AS work this year, you probably have forgotten some of this. It's also a really commonly mucked up area. So what really helps with these questions is to do some good graphs, or at least sketches of graphs. I've done those using GeoGebra, but I'll also do it by hand badly so that you can kind of see what I want you to do in exam conditions. So the first question here is one where we're given a quadratic, and the quadratic is this one here, and it's an expanded form. So when we look at it like that, the only thing we can really see for our graph straight up is that it's going to be an upside down parabola, and it's going to have a y-intercept of 2, right? It's pretty hard to see anything else. When we put it into vertex form by completing the square, we can draw that very, very easily. And we need to do that for all of the rest of these kinds of functions questions. When we've got a parabola, it's a function, right? So I'm going to show you a graph now of the most basic parabola. Where's it gone? Here. Right, this is the graph. This blue one is y equals x squared. And y equals x squared is a function. It's a function because it passes the vertical line test, right? So for any value of x, there's only one value of y. Get rid of that ruler. So if I pick an x value, there is a unique y value. The problem with it for finding the inverse is that it's not 1-to-1, and that means that it fails the horizontal line test. For example, here at about 1.7, there's one y value, but there are two possible x values. What does that mean? Well, if I reflect that whole function, y equals x squared, in the line y equals x, let's just look at what we get. Now, I know some of you are probably going, oh, we know this already, but there'll be some of you watching who might have forgotten. This is what finding the inverse of a function is all about. So that line is the y equals x line. And you can see that if I reflect the blue line, I get this red line, and that then fails the vertical line test. So the red line, as we've done it, is not going to be a function, right? Because this time I've got one x value, and I've got two possible y values. So it's not a function. In order to make the reflection a function, we have to put a limitation on the original. So we can do that in two ways here. Either we can get rid of that bit, and then when we reflect the blue line, the only bit we're going to have is that bit there. Or we can do the other way around. We can get rid of that bit and just have this bit here. And if we do that, then when we do our reflecting, our function will be this bit down here. And that's what questions in the exam are often about. So here, first of all, we're going to go back to our function, and we're going to find it in vertex form. And then we're told that our 1-to-1 function is defined by this, so the same equation, but just for x is less than or equal to k. And that means that we're going to be working with this bit of the parabola. I'm just going to change my pen size so you can read it better. Okay, so that was a lot of lead-in, but hopefully that will help us do the question a wee bit faster. Completing the square is one of those techniques that has to be completely at your fingertips for AS. So -3 x squared plus 12x plus 2 needs to be rewritten. So I do it by working with those first two terms, and I'll take out that -3 as a common factor before I start. And now we're going to have -3 times x minus 2 squared. What have I done here? Well, I've matched up the x squared, and I've got a minus 4x coming in here. But I've also got a plus 4 here that is then getting multiplied by the -3. So I've accidentally kind of taken out 12. I have to fix that up by adding it back in. So we've got down to y is equal to -3 times x minus 2 squared plus 14. And that's now written into vertex form. Looking at the question, we've got our a and our b. We might as well say what they are. So a is equal to 2 and b is equal to 14. That means that I can draw that graph very easily. I can see that the vertex is going to be where x is equal to 2 and y is equal to 14. Now I've done that nicely in GeoGebra, but you can do that roughly on your page. So here's the nice version of that done in GeoGebra. We've got an upside down parabola and the vertex is here at the point 2 and 14. What we're asked to do in the next part of the question is to restrict this. So we're told the one-to-one function is defined by this: for x less than or equal to k, state the largest possible value of the constant k. So if you've done a graph of that, it's really easy to spot what we're after. We're looking for this. So we want the value that is going to make it one-to-one, and the format is x has to be below a number. So it's going to be that x has to be less than or equal to 2. That then leaves me with just this bit of the graph, and that's one-to-one. So for this question, we're just going to say k is equal to 2. It's only 1 mark, but your evidence for that would be the sketch that we just had, looking like that. All right, so k is less than or equal to 2. The largest possible value is 2. And now we're told that actually they've chosen k is equal to -1. So that means we're getting rid of even more of the graph. We're just going to have the bit starting at -1 that washes off down to there. So it's a very steep bit of one branch of the parabola. So for x is less than or equal to -1, what's the range of f? From looking at the graph, you should be able to see that the range of f is going to be whatever the value is at -1. So f at -1 is equal to -3 times -1 minus 2 squared plus 14. This is -3, so it's going to be -27 plus 14, which is -13. So the range is y is less than or equal to -13. Right, now not surprisingly, the next question is to find an expression for the inverse function. To find the inverse, we reverse x and y, and then we make y the subject. Visually, what we're looking for here is we're trying to put in a mirror line, a reflection line at y equals x, and we're going to reflect this pink bit in that mirror line. So it should look like this. And if you have that picture in your head, it's going to make the tricky thing that we're coming up to much easier. It's also good sometimes to think about the coordinates of a couple of points. So a coordinate, a point on the original function is -1, -13. That means that when I invert the function, I want to have the point -13, -1 on my curve. And that's a really good way to check that you haven't chosen the wrong branch. And you'll see what I mean when we do the function. So we start with, let's start with this. And you need to have it in vertex form for this to work, or the algebra is much, much worse. So working with it like this, we're now going to reverse the x and y. And we're going to make y the subject. So we get x minus 14 over -3 is equal to y minus 2 squared. Fixing up the left-hand side, I'd rather write that as 14 minus x over 3. It just looks better. That's also what the mark schedule did. You don't have to do that, but just having a negative on the bottom line just, to me, looks really ugly. And now we're going to take, at this stage, the positive or negative square root of that side, and we've got y minus 2 here. So what I've got down to is y is equal to 2 plus or minus 14 minus x over 3. So a few different ways to think about this. Graphically, we had this bit, right, and we reflected it here, and we want it to be here. So we know that we're going to want to have all negative numbers in here. Let's put in x equals -13, because we know that we should get this point. We know we should get -13, -1 coming out. So if we put in x equals -13, we get 2 plus or minus 14 minus -13 is 27 over 3, which is 2 plus or minus the square root of 9. And we don't want the 5, right? We want the -1. So that tells me that for this case, the branch that I want is 2 minus that. And that's my inverse function there. So y is equal to 2 minus 14 minus x over 3. The other way to think about this is if you're thinking about the domain and range of this function, they switch over as well. So the domain for f was that x is less than or equal to -1, and the range is that y is less than or equal to -13. When we invert them, that switches. And we have to have x is less than or equal to -13, and y is less than or equal to -1. And that way is usually actually faster. That tells you that if we want the y values to be low here, then there's no way we're going to do 2 plus a number. Okay, so I think when you're learning the function stuff for the first time in AS, the stuff with inverses most students find quite tricky. You need to do heaps of examples. So let me know if you want me to find some in a textbook. What's left? Okay, the next bit is not too bad. We have to translate the graph. So we need a good understanding of what all the bits in the equation do, and we're translating it by this vector. This is the only place you now see vectors coming in AS. This means that we want to be moving our whole graph back 3 that way and up 1 that way. So again, I'm going to work with the function in vertex form. So starting with f of x is equal to -3 times x minus 2 squared plus 14. So g of x is going to be -3. Now to move something back that way, so if I have the x squared parabola and I want to move it back that way by 3, it's going to be x plus 3 squared, right? Here, it's going to be the same, x minus 2 from here, plus 3 squared, and I want to move it 1 up. So it's going to be plus 14 and plus 1 up. So we get this. So don't hang up the video yet, please, guys. We're not done. And plus I've got a whole 3 minutes left until the recording stops. So we have to expand that because we're told that in the question. And that gives me -3 into x squared plus 2x plus 1 plus 15, which gives me -3x squared minus 6x plus 12. Right, heaps to do in this question. Please go onto Google Classroom and look for the link to my website, because I've done a bunch of videos now for AS questions on functions, and they'll all teach, each example will teach you one more tiny thing. And if you've got specific questions on this topic, please do send me an email or Mr. Hawke, and we can set you up with some extra problems. Thanks for watching, and have a nice rainy Wellington day.